this section, we'll take a deep dive into perspective, do some experiments, and possibly learn something new. I certainly did. I'll be doing some traveling. I will visit the east coast of Denmark at 2 different locations, and I will visit the west coast and also a local soccer field. Before we take a closer look, let's see a 2-minute clip to hear what the flat earthers say.
In the flat Earth model, the sun and moon spotlights are perpetually hovering over and parallel to the surface of the Earth. From our vantage point, due to the law of perspective, the day and night luminaries appear to rise up the eastern horizon, curve peaking high overhead, and then sink below the western horizon. They do not escape to the underside of the flat Earth, as one might imagine, but rather rotate concentric clockwise circles around the circumference from tropic to tropic. The appearance of rising, peaking, and setting is due to the common law of perspective, where tall objects appear high overhead when nearby, but at a distance gradually lower towards the vanishing point. Samuel Rowbotham said, "Although the sun is at all times above and parallel to the Earth's surface, he appears to ascend the firmament from morning until noon, and to descend and sink below the horizon at evening. This arises from a simple and everywhere visible law of perspective. A flock of birds, when passing over a flat or marshy country, always appears to descend as it recedes, and if the flock is extensive, the first bird appears lower or nearer to the horizon than the last. The farthest light in a row of lamps appears the lowest, although each one has the same altitude. Bearing these phenomena in mind, it will easily be seen how the sun, although always parallel to the surface of the Earth, must appear to ascend when approaching and descend after leaving the meridian or noonday position. What can be more common than the observation that, standing at one end of a long row of lamp-posts, those nearest to us seem to be the highest, and those farthest away the lowest, whilst, as we move along towards the opposite end of the series, those which we approach seem to get higher, and those we are leaving..."
You're saying that the sun goes down like a bulb moving behind and below the edge of a table. Just moments ago, you said the sun does not go below the flat Earth, but always remains up in the sky.
Leaving behind appear to gradually become lower. It is an ordinary effect of perspective for an object to appear lower and lower as the observer goes farther and farther.
An ordinary effect of perspective, you say? Really? So you're claiming that a coin disappears from the bottom of an ordinary dining table due to perspective? You are clearly pushing that coin behind and below the edge of the table, which you said the sun wouldn't do. The next slide is this one. Okay, so we have a person that walks across a football field and his lower body disappears gradually from the bottom up. And it's claimed that this is just the way things work. Before taking a detailed look, let's learn a simple perspective trick used by woodworkers. To test if a piece of wood is straight and without bumps, you move your eye as close as possible to the surface of the wood and look along the length of the wood. This will reveal any humps or bumps as well as show if it's straight or not. In a similar fashion, putting a camera low on the ground, pointing along the ground, will also reveal bumps. These photos show a small hill in front of the camera, followed by a downward slope. As the person walks down the slope, he disappears more and more. This is because the hill is blocking our view to his lower body. So what they're actually saying is that a curved ground can make things disappear from the bottom up. This does not prove that things would always disappear from the bottom up, like it's inferred in this clip. Here's an example of me at a football/soccer field with the camera at a low height. There's nothing blocking me, and as I approach the end of the field, you can still see the full length of my body. I had hoped that one of those birds would have stepped in front of me, but imagine that they were a small hill that would have blocked the view to my lower body. Okay, let's look at what perspective really is. You will find no physics books with a chapter on the law of perspective, and this is because it's a flat earth term used to describe how perspective works with a twist. They somehow believe it explains why things disappear from the bottom up. Let's investigate if perspective can do that. Looking at the dictionary definition of perspective, we see that it is the appearance to the eye of objects in respect to their relative distance and positions. So, in other words, to change perspective, something needs to move and/or you need to change your viewing angle to see the objects. Okay, that's pretty intuitive. Since it's the eye doing the observations, let's look at how the eye sees objects. Here we have a simplified model where the rays from the object pass through a lens and gets turned upside down and projected on the backside of the eye, where the sensors pick it up. The further the object moves away, the smaller the projected angle gets. And at some point it's so small the sensors in the eye can no longer resolve it, and it would disappear. If we put some variables on this model, we can see the relationship between the angle, the size of the object, and its distance from the eye. Now don't worry about the details, I only show you this to give a brief overview of some of the equations you can find in the companion document, linked to in the description. So if some of the things I show you here piques your interest, you will find more details in that document. We can run a simple simulation with this equation to see if it fits reality. I'm simulating the movement of a 1 meter cube at a constant speed away from us. It does indeed give us nice, straight perspective lines, and the object moves towards the disappearing point on the horizon. We see that although the object is moving at a constant speed, it appears to be moving slower and slower as it goes into the distance. This is perfectly consistent with real-life observations, so this equation looks good to me. As you can see, this equation itself makes no assumptions on the shape of the Earth, but merely models how eyes view objects at a relative distance. Objects disappear by becoming smaller and smaller, but there's no reason why only the bottom should disappear. With this equation, we can calculate many things like what's the diameter of the sun if it's only 3,000 miles up in the sky. This gives a diameter of 28 miles, which fits very well with the flat Earth claims of the sun being 30 to 50 miles in diameter. We can also estimate how far the human eyes can see objects, because we know the average eye cannot resolve angles less than 1/60th of a degree. I did not know this, but the math shows a surprisingly simple relationship between an object's size and how far we can see it. You simply multiply the size with 3,438 and you have the approximate distance at which the object will disappear at. As with all equations I derive, I verify them with an experiment if possible. This time I drew some squares on a piece of paper and tested at what distance I could see them at. This is like taking an eye exam. It's very, very difficult to say where exactly the limit is, but the equation certainly gave me an approximate distance where the squares were either gone or at least very, very difficult to see. Okay, enough math for now, but at least now we have an idea of what perspective is and what it can do. We can now make predictions about perspective. Let's take a step back and look at perspective from a more logical point of view. Since perspective is used as an explanation for why things like coins and the sun disappears, we should identify how perspective can make things disappear. There are only two possible ways, each with their unique root cause. Let's look at the obvious one first, which we have already covered. We will look at an impossibly fast car. When it moves into the distance, or when you move backwards relative to the car, there comes a point when your eye cannot optically resolve the object anymore, because it's too small. This I will call distance perspective. This is not an official term, as I don't know of any official terms, but I use it so you know what I'm talking about when saying distance perspective. How do we test if this is distance perspective? Well, if the root cause is that your eyes can no longer optically resolve the object anymore, then obviously using a telescope lens or a set of binoculars must bring the object back into view, if they're powerful enough. If it does not, then it's not distance perspective. In this case, it is distance perspective because we can see the car once again. So, distance perspective deals with the change in location forwards or backwards by either you or the object. Simple stuff. The other way perspective can make objects disappear, I call view block perspective. Here we have a basketball, and after changing our perspective, it's no longer visible. Yeah, I didn't say it was going to be difficult to understand. But we have to make the distinction between different kinds of perspective to better understand it. To test if this is view block perspective, we see if a change in our location, up, down, left, right, and or a change in view angle can bring the object back into view. In this case, it can, so it was view block perspective. This means there was something blocking our view. Simple. Note, you're not allowed to move forwards or backwards as that's covered by distance perspective. We can also look at a huge basketball disappearing on a super small globe. If it is view block perspective, then we should be able to bring it back by moving up and looking a bit down. And indeed, we can see it. We can view this from the side too. We can see that the water curves and blocks the view to the basketball. And once the view is higher up, we can once again see it. Let's look at a real-world example. Ferries. No, not that kind of ferries. The boat kind. The day was windy, so I have replaced most of the original audio. I'm standing near a small boat club in Frederikshavn, which translates to Frederick's Harbor. The friendly locals offered me a beer after I was done filming and asked me what on earth I was doing on this windy Friday. Thanks for the beer and talk, guys. I'm facing east, looking towards Sweden in the hopes of catching the ferry from Sweden before it goes over the horizon. As you can see here, the bottom of the ferry is still missing, so I got here in time. The window of opportunity is not long, and it only works for large boats, as small boats would just not be visible at this distance. The waves were pounding the small wooden pier I had my tripod on, which made the video very shaky, and it didn't help I was zoomed in at an extreme level. I demonstrated that zooming in and zooming out does not change how much you can see of the bottom. It merely changes the magnification of the image. You can test it yourself and see that it is the case. If perspective is the reason for the boat bottom's disappearance, then we can deduce that it's not distance perspective, as zoom levels revealed nothing more. This only leaves view block perspective, but that means something is blocking the line of sight. What could that be? There is only water. If that's true, that would mean the water would have to curve to block our line of sight, just like a curved ground is needed to make the lower body disappear on the football field. To really drive it home and fully prove that it is view block perspective, I would have to film from a higher vantage point to see if more of the ferry bottom comes into view as expected. I had no way of raising up my camera any further and still being able to point it at the ferry, and I didn't have a drone, so that was not possible. But if you have a way of doing this safely and legally, that's an idea if you are going to repeat this experiment. If you can bring the whole boat into view by zooming, then it's distance perspective, not view block perspective, and you most likely didn't catch the ferry in time. See, I've zoomed out a little bit, and if I zoom in, it's not revealing any more details of that boat. Well, it was a little Swedish. Tack så mycket, that means thanks a lot. So, it does not sound like the Muppet Shows. Let's look at different examples, like the sun going down. According to the flat earth views, as we've seen in the start of this section, the sun sets due to distance perspective. Let's see if that fits the observations we will make. In the ball earth model, the sun disappears from view due to Earth's rotation. We see a person looking at the sun, which is fully visible. At this time, the bottom of the sun has disappeared, and at this point, it's gone completely. We will do some simple experiments. I will be getting on the ground as close as possible, looking at the sun. As soon as the sun has gone down from that point of view, I will get up and look at the sun going down once again. And at this point, it's gone. Now we know what's going on. Let's look at the actual footage. You will notice I will be measuring some time differences. These will be used later on to determine the radius of the Earth. But for now, let's just focus on the sun going down, twice. I am at a west-facing beach near a town called Blokhus. I have laid down a blanket to lie on, and I have 2 GoPros at different heights and another camera with a filter on to look at the sun. I'll extend the top camera as high as possible after I've synchronized the cameras by simply clapping in front of them. Here I'm lying on my stomach, waiting for the sun to go down. I will stay down until I'm absolutely sure the sun is completely down and does not come back. Then I stand up and see the sun going down once again. Let's see the same footage from the GoPros at 2 different heights. Sync, clap, and then I move the higher camera up. Lower camera sun is down now, waiting for upper camera sun to go down. And there we have it. You can do a similar experiment on an east-facing beach or harbor. Here I am in the morning at the harbor near Hels on the east coast of Denmark. This time around, I will start by standing up, and once the sun has risen to the occasion, I will get down lower and see it disappear and rise yet again. The sun is in view now. There's a pillar in the way, but we can still see it anyway. I get down and it disappears. And it comes back again. Hold it. So what? So we can see the sun going down twice and we can see the sun going up twice. What's the big deal? Well, the deal is now we have the root cause behind the sunset and sunrise. It's view block perspective and not distance perspective as claimed. You should never look at the sun through a lens without proper protection, as it can literally burn your eyes. But it's not possible to zoom in and bring the sun back once it's gone, which should have been enough if it was distance perspective. Well, at least right after it disappeared, that is, because if it moves too far away, we can't see it either way. Anyway, simply moving a bit up or down brought the sun back into view. This tells us quite clearly that something was blocking the view to the sun. And as in the case of the ferry, it can only be the water, which in turn means it must curve. Why? Well, because if it doesn't curve, then how can it block the view? If the water was straight and level, then it would be distance perspective that eventually made the sun disappear, but that's not what we saw. Let's have a look at the footage I shot with the last camera that was set up at Blokhus. There is an ND1000 filter on it, which makes it look very dark. It's there to tone down some of the glare from the sun, but it also makes it more difficult for the cheap camera to find focus. To view the sun completely without glare, you would find that it's much smaller than you think it is. But for that, I would need a real sun filter, and I don't have one. I wanted to show the effects of refraction. Refraction just means that light is being bent, and this makes it more difficult to calculate the exact distance to the horizon. It can bend light up, down, and do all kinds of shenanigans. The effect is greatest near the horizon. You can see the round sun gets distorted as it nears the horizon. Lastly, I zoomed in just to show that zooming does not bring back the sun. It's difficult to see as the camera would not focus. If you're going to do these experiments yourself, then I must mention that I went both to the west coast and the east coast numerous times before getting these shots. The thing is, if there are clouds in between you and the sun, then this does not work. The reason is, you will just be able to see the distance to the clouds and no further. It makes no difference if you stand up or stand down, you can only see the clouds. And weather forecasts don't usually tell you if there are clouds several miles off the coast. But I met many friendly people on these many visits. I mentioned I could estimate the radius of the Earth using the 2 time measurements I made on the beach. And I have done so, and I got fairly close. Since I live so far up north, I had to derive equations that took the current latitude into account. It was a bit more complicated than I had hoped for, so I will let the ones that are interested have a look in the document and spare the rest, as the length of this section is already long. The main purpose of this video was not so much to determine the radius of the Earth accurately, but more to see if it actually had a radius or not. You will also find 2 nifty equations for determining the distance to the horizon in that document. In this section, we've seen that the sunset and sunrise cannot be due to what I call distance perspective. This is the kind of perspective that most associate with perspective. To finally put this to rest, let's see how far a 28-mile diameter sun at ground level would have to go away before disappearing in the horizon. We already know this. 28 miles times 3,438, or around 96,000 miles. This is almost 4 times the diameter of the flat Earth. The sun cannot go anywhere near that far away while still staying somewhere on the flat Earth. You can verify this equation like I have. It's not magical math. It gets much worse if we consider that the sun is supposed to be 3,000 miles up in the air. For such a height to collapse into the horizon, it would require 10.3 million miles. The sun would disappear long before it merges with the horizon. So the sun cannot disappear, nor can it merge with the horizon using distance perspective. Even if all of this was possible, then it would still not explain why it disappears from the bottom up first, as this would vertically compress both the top and the bottom simultaneously, and not just the bottom alone. Now you know some of the reasons I believe the Earth is a globe. What you believe is up to you. It's okay, they've gone. You can come out now.